Hello, good morning dear students. Today we will discuss about the introduction to mechanical vibration. The subject title is Dynamics of Machinery. Subject code is 1ET1010602. So the question arises in your mind, what is mechanical vibration? Right? What do you mean by vibration? So vibration is basically related to the oscillation of an object above the mean position. So importance of the study of vibration. Why we need to study the vibration? So majority times you will see that a vibration is a very versatile in our day-to-day life. Most human activities involve vibration in one or the other form. For example, we hear because of our eardrums vibrate and see because light waves undergo vibration. When we speak, it is the result of the oscillation of our sound pattern. So when we breathe, it is also because of the oscillation of our lungs. As we are live, because our heart is vibrating, right? So lot of such applications we will see in our day-to-day life. So when earthquake, so earthquake is due to the oscillation of plates or results of vibration. So more or less vibration is related to the behavior of the system, right, under the disturbance. So where actually the vibrations are utilized. So as we have mentioned, these are the different examples, right? We have seen for a vibration. Most of the how it is useful to the mechanical engineering. So most prime movers, especially diesel engines, have a vibration due to the inherent unbalance in the engines. Or you might have seen the rotodynamic machines, like agitators, compressors, right? So they possess or they produce excessive vibration. It is because of what? It is because due to the unbalanced mass, maybe due to the faulty design or poor manufacturing. Even in we see that vibrations in a rotodynamic machines, turbines and compressors. Even we can take an example of the, threshers. So where we are seeing the vibrating screens. So due to that vibrations in the screens, the size of a different seeds would be separated out. So that is why the vibration is necessary. Generally, vibrations are always undesirable, but it is not the case. In some applications, vibrations are desirable. So let us try to see where the vibrations are desirable, where the vibrations are undesirable. So vibrations can be classified in several ways. Some of the most important classifications are as follows. First is free vibration. If a system after an initial disturbance is left to vibrate on its own, that vibration is known as free vibration. In this vibration, no external force is continuously act on the system. So the example of such vibration is oscillation of a simple pendulum is an example of such free vibration. What do you mean by forced vibration? So if the system is subjected to an external force, often a repeating or a periodic type of force, the resulting vibration is known as forced vibration. So in a forced vibration, continuous force is acting on the system, maybe continuous in nature, maybe periodic, or maybe impact in a nature. So the oscillation that arises in machines such as diesel engines or compressors or turbines or any rotodynamic machine is an example of a forced vibration. So uses and effects and remedies. So the question, we in this particular thing we try to see that what is the usage and effects of vibrations and how we can reduce the vibrations. The effect of vibrations is generally not advisable or it is undesirable. The thing is it basically generates the excessive stresses, undesirable noise, looseness of parts, and partial or complete failure of parts. In spite of these harmful effects, the vibration phenomenon does have some useful effect also, such as musical instruments. As we know that if you want to produce a periodic sound from a drum or guitars, right? Then that screen must have to vibrate. You have to produce a vibrations on the surface so as it will produce a periodic sound. Elimination of reduction of the undesirable vibrations can be obtained by one or more of the following methods. Generally, if it is a musical instruments, then we used to tighten the rods, or we used to loosen the screws. By that way, you are adjusting the tension, and that way you are reducing the vibrations. Right? But when we say about the following methods, that first is removing the causes of vibration. We are putting screens if the noise is the objection, resting the machinery on a proper type of isolators, shock absorbers, or dynamic absorbers. So here you can see on the figure that fundamentals of a free undamped vibrations. So when we say vibration, it has some pattern, right? Just like I say, we have seen the cardiogram. So in a cardiogram also you see that it basically shows the oscillation of a heart after a definite time period. Okay, so same way here you can see that particular particle oscillates about mean positions, right? That is called that is called basically periodic cycle. Here you can see periodic cycle is represented 0, pi, 2 pi, 3 pi, 4 pi, 6 pi. So first harmonic, that is, it starts from 0, then pi and 2 pi. So to complete a one oscillations, a particle moves through 0, pi and 2 pi. So which shows you the first harmonic. Then second harmonic, 2 pi, 3 pi, 4 pi. That is called second cycle. Okay. So how you define the natural frequency, equation of motions, amplitude, that we will see one by one. So here the distance from peak to peak or crest to crest is known as a wavelength, right? So repeating oscillations, that is represent simple harmonic motion. So in this figure we can see 0, pi, 2 pi, 2 pi, 3 pi, 4 pi. So first cycle is repeating after second cycle. Okay, so the second cycle is repeating after first cycle. So in that particular what we have seen, the motion is continuously repeating. So that particular cycle is known as a full oscillations. What do you mean by frequency? Frequency is represents as the cycles per second. The unit of frequency is also known as hertz or cycle per second, Hz. So what is frequency? Already I mentioned, it is a number of oscillations per unit time. What is a period? So time period T is defined as second, and it is time required to complete one cycle, that is 0, pi, 2 pi. So time period T is defined as twice pi by T. Small instantaneous time T is equal to twice pi upon T. Amplitude A, that is represents the maximum displacement of an object from an equilibrium position or a mean position. Here what I observe, that particle moves from 0 to pi to 2 pi. Now in that particular 0 to 2 pi, we have seen that the particles moves through a maximum oscillation, so either on the upper side or on the lower side. So this maximum displacement of the object from the mean position is known either on the upper side or a lower side, is known as amplitude. Displacement. So how you define displacement x? So let us x is equal to a sin omega t plus b cos omega t, where a and b are the constants. Omega is nothing but the excitation frequency or circular frequency, right? That is known as twice pi n by 60, where n is engine RPM or speed of the rotodynamic machine. Frequency is defined as reciprocal of the time period t. So that's why equation is 1 upon time t. Now what do you mean by resonance? Here resonance is nothing but a excitation frequency omega, and there is a natural frequency of the system, that is omega n. natural system, natural frequency of the system is defined as under root k by m, where k is the stiffness of mass, stiffness, and m is a mass. So k by m, what it represents? It represents k is a stiffness and m is a mass. So every mass has some particular tendency to resist the applied force effect. So due to that, any object has its own natural frequency that it can vibrate or it can displace without the application of the external force, or it is the maximum displacement of the object without any external force. So when resonance is omega is equal to omega n, right? So that is the maximum displacement. And here you can initially when in the glass you can see the vibrations, sound waves are produced. So due to the musical instruments, this particular glass has its own frequency, and due to the music some sound waves are induced in the glass, right? And that's why sometimes we can see that due to the higher frequency of the sound, even it will break the glasses of our windows. So same way here the thing is happened, the room is closed and you have increased the frequency of the sound, due to which after some times the this excitation frequency or frequency excited due to the sound waves produced, that reaches to the natural frequency of the system. So omega is equal to omega n, and that is called resonance. So resonance is available in real life application because it damages the physical structure. So being an engineer, whenever you are deal with the vibration, you make sure that excitation frequency will never cross the natural frequency. It means that it should either greater than the natural excitation frequency should be greater than the natural frequency, or excitation frequency should be less than the natural frequency. Okay, so next part we will continue in next time. Thank you.